So the lab for this module is a dry lab. You'll be asked to complete the worksheet on limiting stoichiometry. You will be given a set of reactions wherein you're asked to find the amounts of the products formed given the reactants in the vessel. So the very first thing that you need to do is figure out which of the two reactants will run out first. Once you establish the limiting reactant, you're going to base all your calculations or the amounts of your products from that limiting reactant. So I'm going to show you the two ways or two methods of calculating this type of problems. The first one is the long method, and then the second one is the short method. Okay, let's begin. So here I've already set up the dimensional analysis. So my first objective is to figure out which of these two will run out first. Is it going to be the first reactant, NO2, or is it going to be the second reactant, TiI4? Now to do that, I'm going to figure out the amount of products, titanium 4 nitrate, produced from each of these reactants. So I'm going to do two separate calculations. So I'm going to start with the first reactant, 19.7 grams of nitrogen dioxide. Since it is in grams, I have to first convert it to moles using the molar mass. Once that it is in moles, then I can use these coefficients in order to figure out the amount of product produced. So it's an 8:1 ratio. Once that it is in moles, then I can calculate the equivalent mass of the product produced by using the molar mass of the product. So I ended up with 15.8 grams of titanium 4 nitrate. Now on a separate calculation, I'm going to figure out the amount of product formed if all of the second reactant is used. So 24.2 grams of TiI4, convert that first to moles, this time using the molar mass of that reactant. Once it is in moles, then I can use the coefficient. It's a 1:1 ratio. For every 1 mole of the second reactant, I can produce 1 mole of the product, and then convert that product to its equivalent weight. So I ended up with this number. So now I'm going to do some analysis. Which of the two gives me the least product? So it's this one. So it's the second reactant that gives me the least product. What does that mean? It means that by the time I make 12.9 grams, all of my second reactant will be consumed. It's going to be my limiting reactant. It's going to run out. And so even if I have more than enough nitrogen dioxide to create 15.8 grams of the product, I can't do that. I won't be able to do so. I can only make as much as possible 12.9 grams of the product. Okay, remember, in order to form product, you need to have these two reactants inside your vessel. So your titanium 4 iodide can only produce 12.9 grams. And then after that, you're no longer going to have this in your vessel. Once this is gone, then the reaction can no longer proceed to the right. So that means this first reactant, NO2, is your excess reactant. You're going to have more than enough to produce products, but without this second reactant, you can't do so. So now that you know your limiting reactant, you can calculate all of your products based on that. So meaning to say, this first step, this thing that I'm showing here, is only performed once. Since we know that of this two reactant, this will run out first, then I can calculate or base my calculations or calculate the other products form based on this alone. So I don't need to do that for NO2. Okay, so calculate the other products. How much grams of NO is produced if 24.2 grams of titanium 4 iodide is used up? Okay, and I'm going to do the same thing for the third reactant, iodine. Okay, notice that I'm just using this now as my to perform my calculations. I no longer need NO2. This very first step is only used in order to figure out who is the limiting reactant. Okay. All right, convert that to moles. Sorry. Moles of titanium 4 iodide. And then use the ratio. It's a 1:4. This time I'm focusing on the second product, nitrogen monoxide. Okay, and then convert it to grams because grams is what is asked for. A mole of NO weighs 30.01 grams. And that will give me a value of 5.23 grams. Okay. Okay, so the first one is 12.9. Okay, and I'm gonna do this for the second, the last one. And I got 22.1 grams. Okay, now notice that if I add all of the amount of products, I would add up to 40.23 grams. And if I add all of the reactants that is dropped in the vessel, they all add up to 43.9 grams. Okay. So what does that mean? How come in is not the same as the amount, the mass that is coming out? Well, in is actually equals to the amount that's coming out. What that means is just that there is an excess of 3.67 grams of the unreacted reactant. In this case, NO2 that is still left in the vessel.